Okay, we're going to look at the relationship between the Earth, the Moon and the Sun with relevance to the tides that we experience. So we've just got some rough models here of the Earth, the Moon and the Sun. The Sun is approximately 93 million miles away from the Earth. The Moon is approximately 1/3 of a million miles away from the Earth. So the Moon is considerably closer to the Earth. Obviously the Sun is massively bigger than the Moon. However, because it's so far away in relation to the Moon, the gravitational pull of the Sun is around 40% that of the Moon. So although the Moon is a lot smaller than the Sun, because it's nearer to the Earth, the effect of the Moon's gravitational pull is a lot more pronounced than that of the Sun. Okay. Now, the Earth spins around its own axis anti-clockwise. The Moon orbits the Earth in an anti-clockwise way. There is a gravitational pull between the Earth and the Moon, and that's what keeps them together. There is a gravitational force or pull between them. Okay, so if we just take the Earth itself, let's just leave the Moon to one side for now. The Earth will rotate around its own axis 360 degrees every 24 hours. So if that was our position on the Earth there, in a 24-hour span, we would actually rotate the full 360 degrees. So if we're looking at ourselves in relation to the Sun, then that's why we have night and day, because we actually spin round our axis a full 360 degrees every 24 hours. The Earth also rotates around the Sun in an elliptical shape, and it takes 365 days for us to go all the way around the Sun. Okay, so that takes 365 days, and that accounts for the seasons: spring, summer, autumn, winter, depending on how far we are away from the Sun with the elliptical shape. The Moon has a lunar orbit around the Earth anti-clockwise, and it takes 28 days for the lunar cycle. So the Moon will actually rotate around the Earth every 28 days. Okay. So if we look at our situation there, if that's us at Earth there, and that's the Moon there, okay, so we're opposite the Moon there. When we go a full 24 hours, spin round a full 24 hours, back to the position that we were, in that time the Moon has actually moved approximately 12 degrees. So the lunar cycle takes 28 days, which is approximately 12 degrees per day. So when we move round our axis for 24 hours, to get back to a position opposite the Moon, we have to move approximately another hour. So every day that the Earth goes around its axis, the Moon moves 14 degrees. Approximately 12-14 degrees. So that means that there's generally an hour difference in the tide table. So we'll just have a very brief look at the tide tables at this point, and we can see for Liverpool on the 4th of May, high water 0226 7.9. The next day, high water 0314 7.4. The next day 0419 7.0. So you can see that the time of high water is changing by approximately an hour each day. Okay, so that's the relationship between the Earth, the Sun and the Moon. So just to quickly recap, the Sun is 93 million miles away from us. The Earth is only about a quarter of a million. The Moon is only a quarter of a million miles away from the Earth. And although the sun is massively bigger, the moon has a lot greater gravitational pull upon the Earth. We spin around our own axis 360 degrees every 24 hours. The Earth goes around the sun taking 365 days, hence the seasons, and the moon has a lunar cycle around the Earth every 28 days. So it moves approximately 12-13 degrees per day difference as the Earth rotates 360 degrees.